here we have an example, and what the robot is actually going to do is it's going to follow this purple line. Okay, so this is where it starts, and then it goes here and it moves that way. What we're showing you to begin with is a couple things. First of all, you see all those red dots? That's its current set of particles. In other words, it has no idea where it actually is. The green is an example of where it thinks it might be. And in fact, this is the locally most likely, which is just some way of the robot guessing where it is. Now, what I'm not showing on this map is for each particle, there's also a theta, right? Particles have to represent the state. What do we say our state was? We said it was x, y, and theta. It's hard to show this in 3, so I'm only showing x and y, all right? But for any given theta that I think it is, then I would be sending out an array of sensor measurements, and I think I know where it should hit because why? Because I have a complete map, okay? So what happens is, first, your eye is just going to naturally go to the green thing. What's going on there is that's the set of sensor measurements that it's getting. So wherever it thinks it is, it puts down the measurements it actually got. Now, if it's in the right place, those measurements will actually, most of the time, hit the wall at the right distance. Every now and then it'll go right through the wall because it was a no return. All right? So let me just put it in motion. It's easier to understand. All right, so here we go. So it's a movie. So each one of these changes is when it takes a measurement. And you'll notice there's a clump of particles here. In fact, that's the most likely clump. And there's also a clump of particles there. That's a nice way of saying the robot does not know whether it's definitely here or definitely there. And the reason for that is the hallway is kind of symmetric, right? There are these doors, okay? But there's doors on both sides. So it hasn't yet been able to disambiguate, if this is the center of my universe, whether it's at this area or that area. But let me put it back in motion. What's going to happen is the robot's going to go inside in the room, and you'll notice in this room, in the room it's about to go into, there's a ottoman or whatever that is in the middle that's not in the other room. So once it goes in, yep, there it goes, okay, you'll notice the particles that are in the wrong place, they're going to disappear. Okay. Now some of the rays are still going in the wrong direction because, they're going through the walls, but that's just the no return. And you'll notice by the time we get to the end of the run, you'll notice that it has localized itself very well. Some of the measurements still go through the walls because I'm assuming those were no returns. But just by taking these simple one-dimensional measurements, several of them at a time, and knowing the map and taking its movements, it's able to localize exactly where it is. And that's sort of a hallmark of particle filtering. You start off with a big unknown set, and eventually a whole bunch of particles go away because they are just totally inconsistent with the measurements you get. So when they get multiplied by p of z given x, the likelihood of that measurement is so small that it diminishes that particle's weight a lot, and the next time you sample, and we said this at the end, remember very low weight particles sometimes don't get sampled at all. So what happens is only the samples that are near the parts of the sensor measurements that are consistent survive, and you keep iterating. Also, remember we had the two lumps for a while there because I wasn't sure whether it was this one or that one because it didn't have enough information to know yet. It wasn't until it went inside that room that it had that information. And this is sort of the inherent advantage of particle filtering over, say, a Kalman filter that has a single hypothesis. For those of you who have maybe heard of multi-hypothesis tracking where you end up having multiple hypotheses, one way of thinking of particle filters is it gives me just a uniform and easy way of doing multi-hypothesis tracking.